right, let's get going. For some reason, I have two cursors in my left terminal window. Doesn't make any sense to me. Sweet, the alert went out. Hell yeah. Good morning, everybody. Okay. Let's do this. Okay. I don't know why Twitter's live stream always puts my own audio back in my ears, but that doesn't make any sense to me. Oh. All right, what do we need to do? Oh, we need the link for the Twitch hangout. Oh, actually we could just do this. Hey, Brontify, Bronifty. Welcome back to the stream. Thanks for hanging out. Look at that sweet gifted sub. Was it a gifted sub or did you sub yourself? Either way, I really appreciate it. I think someone was handing out a bunch of, some anonymous user was handing out a bunch of subs yesterday. Pretty cool for a tiny little stream like this one. All right. We should talk about, okay, so what's remarkable here? Within AWS. Okay, sweet. We gotta just grab our link. Cool. Okay. Sweet. Let's do this. Okay, so we set up Synology yesterday. This is sweet. I also backed up a bunch of my own files here, which is pretty exciting. I think we should be... Are we still up? Where is my terminal? Running out of these. Okay. Oh, sweet. Yeah, we're still going. Docker logs. Oh, hell yeah. Okay. So we're still collecting all these metrics from yesterday. This ran overnight. I think what's interesting is that there were a couple of points where we just didn't get anything, especially from AWS, where it wasn't a cold start. And I think this is them playing around with more of the proactive initialization stuff we've talked about. And we've talked about this a lot. I wrote a blog post that got kind of blew up a while ago about this, but there are a few cases where Lambda will warm up your functions for you, and they don't tell us about all of them. I assume they have some kind of ML model here that will predict when an invocation is going to be needed and go ahead and like make that sandbox warm ahead of time. I'm going to bring up the music just a little bit. All right, Chad, let me know if that music is too loud or too quiet. Cool. Okay. And what's happening is that they're spinning up your Lambda function for you ahead of time. And this can happen when you have just kind of regular traffic, which we're doing, right? We're making this request every 15 minutes. But we're also, I think, one thing I want to do is talk a little bit about why they would do this. So basically, this is a long blog post. I'll put it into the various chats here. But this blog post is going to cover all about why, like how you can spot when Lambda warms up your function for you. But I think maybe the more interesting thing is like why they might do this. What's a little infuriating is that what I really want them to do, and I think what most developers would appreciate if they warmed up Lambda functions for you every time you deployed as like a solo developer. So that way you as you're working on it, you never get a cold start. Vercel does this. I think it's one of those things that like Vercel does on top of Lambda that they do well. And I wish that other like AWS themselves would do this, because it's just a nice feature, right? Like you deploy a new application and you get to test it. You don't have this like crazy cold start. But what AWS is actually doing is sort of looking at it in aggregate. They're looking at, let's see, okay, this is kind of one of the reasons. This is how you detect it. But what AWS is doing, okay, so this is what I want to talk about right here. This is the chart over a day of cold starts versus proactive initializations for a function. And you can see where we just get more and more proactive initializations as the day goes on. And I think a big part of this is this function itself has pretty consistent traffic. And that means that Lambda probably knows that you're going to get a request. And as a result, they're going to try to kind of create that sandbox for you ahead of time as best they can. And I think the reasoning is just simple. They're running this large distributed system. They're running this very large heterogeneous compute distributed system, which means they're trying to balance load across all these different customers that are going to do all kinds of different things with the CPU, and have different demands for resources, for network, for memory, for disk, whatever. So when they can take these advantages, when they can say like, hey, we think like with 95% certainty this function will be used in the next 5 minutes, we can spin that up ahead of time. And I think they're just taking that opportunity. That would be my guess. Again, that's just speculation. One of the causes they did tell me was this, like, at the time, I don't know if this is still true, at the time, this eager assignment thing where, hey, Nacho, good to see you again, man. I just talking about proactive initialization because we got a bunch of them in our metric results from yesterday. So there's, I guess this is a little tricky to see, but actually more easy to see is all these gaps. Hey, Lerlek, welcome back. So see all these gaps in the Lambda function specifically? So AWS, I think this is such a simple function that it's much easier for them to proactively initialize or keep it warm than it is for any of the other ones. So this one is just like, there's much more gaps because they're keeping it warm longer because they know that I'm going to, 15 minutes are going to go by, I'm going to request it because I've been running this overnight. These are all local points. These are all from our Synology setup from yesterday. So it's all sitting right here on my desk. I don't have the camera set up anymore. But we set that all up yesterday. We got Docker running. You can see that here. Container manager. Container. So I owe the kind folks at Synology a little bit of a write-up about this. And I think one thing that's interesting is that I wanted this to be more like a Linux system than maybe it was set up to be. So I had to do a few things with the permissions for those of you who were hanging out yesterday. We had to make a few changes, but now I can like effectively run Docker pull from my AWS account. So I can pretty easily like build something on my laptop, push it to ECR, the Elastic Container Repository, and pull it down. So we should work on that a little bit. Anyway, the proactive initialization thing. Can you leak your AWS keys and access to some compute? You can just DM me. I'll send you some AWS credits if you really need them. But if you don't spend them, I'm never sending you credits anymore. Anyway, so what happens is that Lambda is this massive. They have this control plane for individual sandboxes. Yeah, okay, that's what I thought. Let me know when you have a project to work on. The request comes in, they run it to a sandbox. That sandbox is running. Another request comes in, they don't have a sandbox. That's going to initialize, right? So it's going to be a cold start right now. So this request is stuck. It's pending right here. Then what happens is, okay, let's say that request A finished. So it's done. It's returned to the user. Now request B would be assigned eagerly to that original sandbox 1 while that sandbox 2 is still warming up. And I don't know if this is happening anymore, actually. I had a couple of friends point out that this may not be occurring anymore. But I still see these proactive initializations all the time. Like we still see a ton of this data. So it's definitely, they're doing something. Bronify, Docker is incredibly handy as a build tool. Yeah, I don't use it as much. I use it a lot in terms of, Eliver, thanks for the follow. I use it every day for this project I'm working on, cross-compiling, like just as a builder, right? Like we're literally, like you're saying, we're only building. We don't care about actually Dockerizing or running, like using Docker to run the application. We compile it, we copy the result out. That's fine. I think all of our other applications at Datadog, I think we're all on Bazel right now. I don't think we have any like actual Docker. We have like Open Container Image, OCI format. I don't know if we have like Docker, the command. Anyway, so, and then, yeah, you can kind of see that this is like sort of the trend. So very, very cool feature within AWS. Very, very cool capability. But let's go ahead and look at the code we were working on yesterday. Let's write some Rust today. We didn't write any code yesterday. We did all infra and hardware, which I think was kind of fun. It was a big change for this stream. It seemed to be popular enough because people tended to enjoy it. So, but what I want to do is make a couple of tweaks. So We can ignore the NAS for now. Let's go back to our main editor, NeoVim. Go to curler counter. What do we got? Oh. Oopsies. So we should probably commit the Docker file. I don't know. Hold on one second. I'm going to go fuzzy. I don't know what this file is. I think I accidentally copied my env file in here. Yeah, I did. That's exactly what it is. All right. So let's push up this Docker file. And as a reminder, all of these, everything we're doing here is open source. So I'll send you the link to the repo. Okay, so now we're Docker building. Okay, so this is all going here. I will post it in all the chats. No README. There's a license though. There is a license. I got yelled at on social media for not having a license. I was told it wasn't, quote, open source. So I added a license, but the license has a minor addendum. a minor addendum, which I realize is probably trollish behavior and people will be nonplussed about it, but shout out to anybody who reads the license or the terms of service, because I found it's not many folks. All right, we got your Docker file up here. Okay, sweet. We're gonna try not to leak any more API keys today, but if it happens, I'm not gonna be upset. It happens, you know. We leak them, we rotate them. That's good practice. Bing MMO, thanks for the follow. Welcome to the stream. Thanks for hanging out. All right, let's write some Rust. Okay, legal and binding. That's exactly right. You, by reading it, you set your eyes on this. You've accepted those terms. Chat, what do you think about the car seat in the background? Is that good for the vibe of the stream? My wife commented on it yesterday. She thought it was funny. Okay, so we have this Tokyo main loop, but there's some problems with this. First off, we're not concurrently awaiting these promises, so we should use a join set to do that. And the second thing that I'm thinking of is we're making one request at a time, and we're just checking to see if it's a cold start or not. Why don't we make like between 2 to 4 requests? Because what I'm trying to do is outguess proactive initialization. Sorry, for bring it all back to the blog here. I'm trying to outguess whatever model they're doing here, right? Whatever system is keeping these things warm. I want to see if I can, you know, juke it out. So maybe what we'll do is we'll pick like a random number, and then we'll just take the, what would be fair, chat? Would it be fair to take the slowest request? We could write the points. It doesn't actually matter, right? We could just write all of the points. Whatever we get back, if they're all cold starts, just write them. And if you have more than 1 point at the time series. So this is one of the beautiful part about time series data. Here, all of these are 1 point, but I could send 5 points at the same timestamp. And because these are histogram metrics, those will all still count, I believe. So maybe we do that. Maybe just send multiple points. That, or we could do like a trimmed. We could throw out the slowest request and pick the second slowest. I think that's kind of a common trend. Boom, boom. We'll try it out. Let's get the code running first. Okay, write some Rust. What do we got? So we wanted to do what are we doing? Let mute JSON result, JSON from string response and wrap. Okay. We get the response. Okay, request.get. All right. So 2 awaits here. We need to put this into a join set. We don't want to await the promise there. So we need a Tokyo join set. No, what is it? Is it? Oh man. I want to say it's maybe task. Join set. Yay. Okay. So what's a join set? This is cool. So if you're a Node.js developer, this is like promise.all on steroids. Does that make sense a little bit? We get instead of an array of promises, you have a set. So you have the same properties of a set you would expect, right? You have a unique key and then a value, which is the future. When you hear future, think promise if you're coming from JavaScript. So we have this task, this asynchronous task, which will eventually complete, and this set will track them all. So this can be used to await the completion of some or all of the tasks in the set. The set is not ordered, and the task will be returned in the order they complete. So that's sweet. So we'll just get them back one by one, and we can kind of wait for them all. We're not dropping is a Rust term for freeing the memory or just deleting it. We don't need to worry about that. So here's kind of the example. This is what's going to get me, this async move. So Rust is a language that has very strict memory guarantees. Only one function can hold access to memory at a time without, some sprinkles and fairy dust on top. So this variable I is now owned by this closure within the move. That's what the move does. Move says, okay, take everything in this closure and move it into itself, or take every variable from outside that we're referencing in this closure and keep it ownership in this closure. We have to do that for Azure better. Yo, King Hits, welcome to chat. Azure is not better. I'm just gonna stop you right there. No, it's just hey, Sresha Python, welcome. Neovim goated, by the way. So getting back to the join set, GCP. I like GCP. Actually, I like all three, but if I were gonna rank them, official personal opinion, not affiliated with my company or the badge I wear is the AWS hero, but yeah, I would put AWS on top, then GCP, then Azure. Although, what I think is so interesting about the OpenAI developments, I think Azure is suddenly now looking a lot more stable than where I think GCP could go. Linode, no, I mean that's just not the same. Linode is great. I've used it. I mean, I'm now I get to be like I'm all in the self-hosted game because I have this Synology box sitting right here under my desk. So Linode is fine. Headcenter is great. But they're not the same. They don't offer the same. You have to, that's like bring your own everything. There's some value for having, like RDS is an awesome service. And whatever GCP or Azure's database services, I'm sure is good. Blob Store, objectively incredible service, S3. Yeah, I know Linode has some of those primitives, and I think Linode also has Blob Store too. So they're getting there. Cloudflare is like similar along there. Google's under poor management. I would agree. I think they have a couple of problems. They don't have skin in the game. GCP, like Google itself doesn't run on GCP, so it's like a side hustle. It's not a core part of the business. And at the same time, I think they, so they have moments of brilliance that I'm really appreciative of. Cloud Run, for example, excellent service. I think Soren is the name of the PM. He's great. The service is fantastic. Like if you like Vercel's experience for deploying, something simple right out of like GitHub very easily, Cloud Run is not too far away from that for container images. It's just not. They give you, instead of having like Amazon ECR and then Fargate and having to like string it together with a load balancer, you get all of that right out of the box, and you get this really good serverless pricing, which means you pay by request if you want, and then if you don't, you can just pay for always on, and it's like reasonably cheap. So it's a pretty incredible, it's like one service, one move. And I think they have support for like build pipelines. That's like pretty doable. I haven't used that. I've just pushed my container image. So don't quote me on that. But yeah, I'm a fan. I think Cloud Run is awesome. Like they could, a lot of people could learn from Cloud Run. UDEF, a good salesman. I'm just a user, man. Like you watch me here every weekend, 2 days a week, and then I write software full time. I've done it for 12 years. Like picked up a few things. Still using Copilot though. I'm a fan of Copilot in my editor. Okay. Oh yeah, join sets. Okay, so what are we gonna do? We are going to join set new. Oh, well, welcome to software. Create a new join set in the main loop. Weather app. I did a weather app a long time ago. I did for skydiving. I did a wind forecasting and like live wind app. That was pretty fun. I should have made it a mobile app. I didn't. I opted for something different. Use whatever IDE you want. Eventually, you'll use Neovim. Dax says I have to be more prescriptive in my advice. He said that's what I'm missing. So use whatever editor you want because eventually you'll come around any of them. Dun, 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 dun. And then how do I use this join set again? Do you push or do you assign? I think you push, right? No, you set.spawn. Set.spawn. Okay, async move. Okay. So let's try this. So we should be able to move all of this into the closure. Oh no, because this has to be one promise, right? Oh. Mm-hmm. Oh yeah, we need to put this in. Okay, that's fine. Is there a reason I'm using Rust right now? Not for this. This could be anything. I was using. Is this? Can I do this in a? I might not be able to. I've been writing a lot of Rust for my job lately. I have been writing. Hey, I don't even know how to pronounce this name, but Ozg. Anyway, welcome to chat. Thanks for hanging out. Hey, nifdev, C++. I'm so scared of C++. Because every time I've used it, it's hurt me. Yeah, so I'm working on this project right now. It's all Rust. This is the PR we merged on Friday. So, yeah, I guess lacking on the PR description, but it's a really big. It was a whole team effort, so everyone had the context. So I guess I'm just working in it a lot, and it's familiar, and it's also fun. I think Rust is a fun language. Am I? Oh. Okay, a few likes on the old Twitter. Cool. Okay, where are we? Oh yeah. So we want a control for this. Do. Okay, so set.spawn async move. The real question is, should I wrap this in a future, this whole thing? Or what do we want to do? How do I want to do this? Oh, I know. There's got to be an example of like spawning a larger task in this. No, I don't want that. Yeah, wait, why don't I like just wrote one of these. Why don't I look? So we need, I forget the syntax for this. It's one of these is wrong and I don't want to, I don't want to sign in. I know where it is. Because there's, you either need to specify a closure or you get one implicitly. So the closure is like the two vertical lines. Where would this be? Metrics. Datadog is a W name for real. I mean, I didn't invent it. I wish I did. I would not be living in a crummy little apartment if I invented it. No, this should be fine. I should be able to just wrap this in a... this entire thing should just be one closure that I can test. Maybe I need to... How do I... Blah, 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 non-blocking unit of execution. Yeah, exactly. Yeah, so I should just be able to perform some async work. That's exactly right. And then return from it is a result. Yes, it's okay. No, this makes perfect sense. I think this is right. I think I'm overthinking this. The last thing I return from here, or if I just do the implicit return in Rust, you can just do that. Oh, it's okay. Duh. I'm an idiot. This editor complaint is just helping me. So this is cool. Rust will tell you both where the error is and then where, like, quote, the cause may be. So here I've just got these old references that I need to change because right now they're gonna like I have this set of this set of futures that is gonna return. That guy Doru, AJ stream, no way. Hey, that guy Doru, welcome back. We've been, I guess I was on vacation last year. I was catching fish, man. I posted a bunch of fish I caught on Twitter, and I think I lost like 300 followers. So I was fishing last weekend, but I'm back. So anyway, yeah, the Rust LSP is just telling me, I don't know how I missed that I'm referencing this variable that isn't declared. It's not in scope because it's been moved into this closure or this task, and I need to fucking fix it. That's all. How do we await? We joined .await. Yeah, no, join set. Build task at spawn. We don't care about this. While let some. Okay, this is the magic. Literally gone fishing. Yeah, man. I mean, I grew up in the Midwest. Fishing's great. It's a great, I think I really like being on the water in any way, and fishing is just like a way to not sit there and be totally bored. I'm not really into like the power boating. I got into fishing because I like kayaking and canoeing. And it's just like a nice thing to do. While let some res set join. Set.next. What? Oh, join next. See, Copilot, close. Remove the await. I don't think I need this. Here we go. You keep what you fished? Sometimes. Not this time. Oh, King Hits. Can you explain to me how does a lang like Python actually convert over to ASCII so the computer knows what to process? It's not ASCII. This right here, I mean, these are UTF-8, as you can see by the character encoding here, but you could just think of it as ASCII. It's just that these are 8 bytes instead of 4. I'm not using anything that special. Forget about that. What you're asking, are you asking about how the computer interprets your Python code? Like, how do you go from writing Python code to running Python code? Yeah, so the magic is the Python command. So this right here is the Python interpreter. And what that is doing is running what's called a virtual machine. And that virtual machine simulates or is similar to your actual machine, and it tries to emulate it. And what it does, the reason Python exists and Java exists and actually like Go to a different extent all exists is they have this intermediary representation or bytecode that can run anywhere. So your Python code can run on any architecture on any computer, and the reason that works is because this Python program has been adapted to run, in this case it's running on my network attached storage device, so it's on Linux, right? But if we split the tab and we go back to my MacBook, now this is weird, hang with me. The left pane is SSH'd into this computer under my desk, and the right pane is the stream machine you all are watching me on. This also has Python on it, and it's on Darwin, but it also will run the same code and return the same result. So how does that work? That's the magic. That's what Python and Node and .NET and Java all strive to do, is to create one language, one semantic syntax that can be the same everywhere and be executed everywhere, return the same result. And then they write this virtual machine, which is the Python binary, that command we just ran. They write that and adapt it for every language, or for every architecture, for collections of CPUs and hardware. And that is why your code works. So what's happening is Python will interpret your code into bytecode, and then the Python interpreter on your machine will then know which machine instructions to call. If you want to talk about machine instructions, we should talk about a super cool tool called ODB. Where is it? Bum, 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 bum. So let's go to this. Godbolt is a tool that will show you the instructions for any of the code you're writing. So we can choose what compiler we're versioning, what compiler we're running, what architecture we're targeting. So it's x86, but we can also target ARM. Does it do ARM? ARM. Hey, ARM v7, ARM GCC, and then Clang and GCC are different compilers. Yeah, so this is this is the machine code you're actually running. So this is the square function, and it's so cool. So it will tell you what like the name of it is, and then see how it highlights. The coolest thing is see how it highlights what variable is on the left side of my screen versus on the right side of my screen. See how cool that is? So this is mostly for compiled languages. I think would it do Python? Yeah. Boop. So Python has its own virtual machine. These are their own instructions. These are Python instructions. Right? So yeah, that's assembly, not machine code. That's correct. Nifty, sorry, I misspoke. Relatively accessible disassembler. Yeah, it's great. Let me post this in the chats. I'm too lazy with some of my verbiage, and that I need to get better at. It is not machine code. It is not assembly code. Or sorry, it is not machine code. It's assembly code. Stuff to use GDB for stuff. Yeah, I mean that'll happen. Anyway, this is cool. If you're ever wondering what your program does, here's another cool thing. So like, let's look at some Rust code. Okay, so let's do like a. Let's just do like a print line, or is it print line? No. Yeah. Why did my compilation fail? Oh, there we go. Boom. So this is about, sorry, print line. This is about 98 lines of code. Not too crazy. Oh, I got my, open the stream, see assembly, close it again. George, welcome back. We're just talking about Godbolt. But if we add, I think if we add, is it, yeah, so let's add some formatting, like hello, and then, so now, we went from 90, this is the exact same instruction. We went from 99 lines to another 143 just to interpolate, just like this. It's crazy. It's like crazy how fast these instructions add up. Hey, Boris, Rust boy. Boris is in the YouTube chat. Hello, Boris. Hope you're doing well. Congrats on your exit and selling to Cloudflare, selling Baselime to Cloudflare. Someone was asking how Python runs ASCII, and I had to talk a little bit about how computers work. How many data points? We have a lot of data points. We need more data points, but we have a lot right now. Yeah, we want to control for, so the biggest thing is that AWS gaps are coming in because these Lambda functions are pre-warmed. They're being proactively initialized. So we're using a Rust join set to get multiple results so we can run a couple of cold starts at once. Oh, we need to await this. Right, I think that makes it not a future. Option result. Oh no, whoopsies. Result.await.unwrap. Is this a future? Why would this be a future? It is, future option. Oh, wait, I think we do need join set to be, yeah, it is join next.await. There we go, okay. Oh, okay. Boom, boom, boom. Thank you, Copilot, for refactoring my code for me. Oh, no, this is not, this is some. None. Use this syntax instead. What did I do? Oh, just none at all. You talk to Copilot yourself to the computer? Welcome back, Monster Vacky. None is an inner value. And I guess it wouldn't matter, right? Because there'd be none here. But that would be weird. What is that emoji that guy ordered? That is Heim. Nice. Yeah, we're doing a little Rust boy action. Oh, I've entirely ignored posting on the Twitter feed for the live stream. Backseating. You should backseat. There's the tweet. Backseat Rust programming. Let's go. Cool. Okay. I forgot to make the tweet that we're streaming this live on Twitter, and that was my bad. George, I'm not sure yet. So actually, the vercel thing is fine because I haven't changed these applications in a long time, so they don't have that pre-warming set up. But if I deploy them again, they'll get them. We control for this too, right? Remember again that okay. So let's take it back. How is this working? All of these functions return a couple of checks. So the first thing they return is how long the handler's been took to run, how long it took to statically initialize, the result of whether or not this was a cold start, and then the uptime of the process. So vercel's pre-warming features will warm the node process, but don't actually initialize your variables. So the cold start thing doesn't work for vercel. So we check both. We check the process uptime, and I think if it's been up more than a second, we throw it away because like the end-to-end latency for these requests has all been, even the P99 have been like 600 milliseconds or less. So we can pretty confidently say, okay, if the process has been up for more than a second, it was pre-warmed and that covers at least the vercel's warming. The cold start result with Lambda does statically initialize all of your functions all of your function code when it proactively initializes your function. So then we can just check, we can test this result. Either way, we discard the point if we see that. So what we want to do is just increase the odds that we're going to get more cold starts, basically. That's what we're trying to do here. Okay. What is the compiler yelling at me for? This argument has type result function response join error. Oh. Where is this mad? Why is this so mad now? Consider using result expect. Oh. Oh, because it's a join. Okay, so I have a vector of now, which could have a join error. Yo, how's gaming? Thanks for the follow. Now we have to move it, or we could clone it. Okay. Method clone exists for enum, but the traits were not set. Okay, so this is like some classic. Now we're in the Rust shit because what's happening is this is a result that's coming in for my join set. We unwrap it, but now I want to push it into this array or to this vector, and I think do we hand it off to another method? Yeah, we hand it off to another method. So we hand it off to put metrics. So I think that's what it's complaining about. Function URLs will be dropped here while still being borrowed. Oh, this is new. Binding function URL. Oh. That's fine. I can go in the loop. Wait, what's it complaining about? We got two things. Function URLs does not live long enough. Bar value does not live long enough. Oh, is that because I put it in this into this spawn? Yeah. Can we do this? I mean, this could just be a constant, right? Oh, how does Rust handle references, pointers to vector elements when new elements are pushed? I switched from vectors to list because it doesn't invalidate my ref pointers, something last week. I looked at this before. I mean, it's a list of pointers. If they get moved, they get updated. And I think the struct itself holds the references, if that makes sense. Like the vector itself holds the references. All right, this wants... These can be static, that's fine. Oh, it's mad about that. Okay. Let's try... Why would this be a problem? We move it into here. Oh, we can clone it. We should just clone it, yeah, because this is a string. We have two strings. Oh, that's what's going on. So these are now refs. These are string slices. That's why it's getting all yelly. In Viber, welcome to the stream. Thanks for hanging out. Oh, this also won't work because this join set will... Oh, we need to break. Why is my editor hanging? There we go. All futures settled. Do we say settled in Rust? I don't know. It's still new at it. Irrefutable. A lot. Do we need a loop in here? Really? I'll look. I'll have to Google that. Are you gonna post the benchmark on X? Question from Frenzy on YouTube. I post the initial results already. So these are the results from last night. This is like the overnight data that we collected from our Synology. So it's still running though. Like we're still getting the data. I just want to get more data faster. Where were we? SSH chat. What terminal? Oh, here we go. Docker logs. Yeah. So we're still collecting data. Still got some. Still coming in. Many points. Many points. I posted them. Are they not? Yeah, they're here. They're right here. Alex Goldman. Why is this guy on my Twitter feed right now? Yeah, let me know if you here. I'll. I guess you can't see that. That's a TweetDeck link. Isn't it supposed to be while let something your option? Probably. Oh no, don't pin. I want to copy this and share it with YouTube chat. Okay. Where were we? Oh, like this should be some? Yeah. I think you're probably right. Here we go. Yeah, so this shouldn't even match. We don't even need to match anymore. Ah, that was the problem. That was why that code was so weird. Boom, boom, boom. Thanks for that. There we go. Okay. That was why that was so weird. Boom, boom. Okay. Number to expect. Yeah, we don't need this. The syntax is goofy. Now borrow checker me. Wait, really? Okay, that solved a bunch of stuff. What? Oh, yeah, we don't need this. Dun, dun. Yeah, I think vercel's doing a great job performance-wise on the Rust wrapper. What I want to do next is actually do some some of their streaming, because they've done a ton of work on the response streaming. They had it before AWS had it because they built it themselves. Remember again, draw. Did I type it in wrong or no? Why it's not showing up? Okay. Remember again that Lambda has like this. Let's just get draw here. Where do we got? Yeah, remember again that vercel's architecture has like a CDN, and then they have this K8s proxy server. That, or I assume it's K8s. I don't know if they say that, but I'm not sure what else it would be. They're running their own invoke plane. They're running their own invoke plane for Lambda, so they're not. George, this is totally fine. This is healthy. This is not everything. This is per project. So when I started this project, we created a brand new Excel draw file. I don't do what Milky does and like create one for everything. All right, that's not true. Here it is. I'm sorry. You got me. I thought I deleted this. I don't know what else I have in here. This is only for like a couple of things though. This is only for like the reInvent talk and a couple other, yeah. Oh man, this is some old stuff. I actually use these in my slides too. Yeah, mine's way shorter than that. I don't have like everyday stuff. This is like where I create, these are screenshots that I needed for my blog. So yeah, for like this, where do you think all these came from? You're watching the magic right here. This is how it starts. This is how it works. Okay. What do we have to, oh yeah, argument that function URLs does not live along this is borrowed for static, so it has to be static. That's fine. We can just we don't need to make it static if we copy this. Yeah, that should work. Okay, no more errors. Thoughts on self-hosted versus serverless dramas? No middle ground on text Twitter. There's never going to be a middle ground on text Twitter. That's fine. The real question I think a lot of people have is like, how can you create a project that might get popular and not break the bank? And on the one hand, in the early days of the internet for me 10 years ago, every time something would get popular on like StumbleUpon, which none of you probably remember, but StumbleUpon was a cool website that you would just hit, like it had like a little toolbar that would run it at the top, and you would just hit next, and it would like take you through different random websites. And then eventually that led me to like Dig and Reddit and Slashdot. And then when those websites would publish something popular or something would get popular, they would just be down. They would just be down and impossible to access, like completely broken all the time. And you just have to like bookmark a website and come back to it in like a week after the internet got over itself, because nobody, like not only did nobody think about deploying an application at scale, the tools to do so didn't exist. So on the one hand, the $96,000 vercel bill is out of control. On the other hand, there's something to the fact that like the application stayed up and worked totally fine. So my advice is to, if you're good, like this doesn't fit something that's like all for free. If you're building a company, you're building a product, make your unit economics work. And from there, focus only on your business. Because then that's why I got into serverless in the first place. Like I was building products for paid users, and we knew that we could make X amount of dollars per customer that we onboarded. And we knew that our Lambda bills was less than that, like a tenth of that. So it was very easy to just say, just put it in Lambda, forget about it. Because why would I ever, I can do more work improving the application and make more money and sell to more customers than I would chasing down the cost of my infrastructure. So I think it's like on the one hand, it's pretty cool that these like applications, like even Blue Sky, like they go viral and they all stay up. And that is not just self-hosted, or that's not just serverless. That includes Fargate or AppRunner or even Kubernetes in some ways. But for the most part, like that's a good thing. That transition we went to from the internet crashing everything that it loved to now it being up and working and people are getting a big bill. It's a good thing. It's a step in the right direction. I think that we as it's raining pretty hard now. Hold on. Oh no. I think that we as software developers need to be better about knowing the cost of the services we're going to use before we use them and before they get crazy popular, and also knowing how to throttle them. Hey Marcos, welcome back. And thanks for the follow. I forgot who that was. Let me look. Hold on. Sashin Verma, thanks for the follow. I got a little bit of rainwater on my brand new Synology. 1 second. Rainwater, just water. So I think it's a good thing. Having that option is a good thing. At the same time, it's true, like, you shouldn't shove a whole API into a vercel function for the most part. Probably not the right call, right? If every time a customer loads your page, they're going to hit a bunch of these vercel functions, it's going to get really expensive. Lambda to a lesser extent, but eventually that's true as well, right? So caching is a huge one for any kind of like place you can cache, for sure. For interactive bits, if especially live interaction, if you're going to have an API, at a certain point, it doesn't make sense to keep it in Lambda. You can keep it serverless, you can keep it on Fargate, you can keep it on GCP, but it'll just be cheaper to run it as like a container. Ian, welcome to the stream. Thanks for the follow. Frenzy in YouTube asked, what are some of the best resources to learn serverless stuff? Awesome question. If you're brand new to serverless, I think there's a number of, I think what you want to pick up is like if you want to learn serverless in AWS, which is what I would recommend, you want to pick up like a Cloud Guru or, one of the guides to learn AWS. Stick on the free tier. There's a bunch of videos. I should probably do one. I've been kicking around, what to do on an AWS account. The very first thing I do is I create a lockdown user. So you have your root account, then I create an administrator user, and then everything I do, I use through the administrator user. That's the first thing I do. The second thing I do is I create billing alerts for like $1, $5, $10, $100, and $1,000. And I turn those on and make sure that they work right away. Like I'll get an email if I get a bill. From there, it depends what you want to build. Lambda is a good place to start for sure. It's always in the free tier in terms of you can always use, I believe it's 1 million invocations a month. Is it 4 million or 1 million? For new users, George, I always recommend $1 just so you get used to it. Because that way you'll know if you're getting close. Because in a lot of cases, you don't realize that you're doing anything that causes you to incur $1, like $1 price. And that's what I think people care about. AppRunner tip you gave me in clutch, $10 a month versus $40 ECS. Yes, AppRunner's dope, Haas Gaming. I love AppRunner, and I'm scared they're going to shut it down because I like it. AppRunner is a free. It's a container with a free load balancer. So if you run ALB on Amazon, AWS ALB, it's going to cost you $20 a month. For the IP is $4 a month, and the load balancer itself is $16 a month. So you're always going to be paying that. Whereas with AppRunner, you get that for free, basically, but it scales, at like a more expensive container increment. Where the hell is the free tier? 1 million free requests per month. So this is why I usually recommend Lambda to start. 1 million free requests per month, and then 400,000 gigabyte seconds of compute time per month, usable for functions powered by both x86 and Graviton in aggregate. That's great. And you get 100 gigabytes of response streaming. Yeah, free load balancer. I mean, you pay for it, but like, yeah, it's rolled into the cost. It's a big shared load balancer. So yeah, I guess rounding out the thought on self-hosted versus serverless drama, like, there's something to be said. Like, would that Kara app have even been built if it wasn't serverless? Like, if they self-hosted it all and they were going to run it all on Coolify, which you can do, would it have gotten there? Maybe. Like, maybe it wouldn't have launched yet. Maybe it wouldn't have. There's a ton of things that you get for free in serverless runtimes. But yeah, at the same time, like, you have to be on your unit economics from the beginning with AWS, with any cloud. I think AWS also has a surprise bill problem, just like vercel. So it's something to think about. They do. Vercel does have billing alerts, and they have Vercel has billing alerts, and they have billing limits. So you get what is it? Hold on. Yeah, they have spend management right here. So you can set the alarm amount. You can do everything. Oh, you've been using Puppeteer on Lambda? Oh, that is brutal. I haven't. I could do a little stream on it. I spent Friday afternoon on a call with Melky, helping him get his Go project off the ground and running in Lambda. So I'm hacking around Lambda a lot more now. I can probably help with that. So yeah, you can also turn off production deployments. You can like turn them off, if you want to. So I would say Vercel's pretty good about this. But yeah, like it's just like. Is that for Go? Yeah, it's for Go School. The problem with the 96K bill story, the 100K bill story was like, they put a bunch of their logic into Vercel functions, and then they call them every single time the app loads multiple times. So it's like every user is costing them like $4 or $5 a day every time they're using the app. And it's a great app, but like that architecture would work fine if it was in a container. But because it's built by request, you're making all these requests, then it's not as fine. And like, yeah, you can combine them. There's a bunch you can do. But I don't think the discourse should be necessarily around like self-hosted versus serverless, because you could very easily, even if you put this, even in Vercel, you could have limited this, right? You could have prevented that shock. And you can go up a level and say, okay, we can go to AWS, and you could just like, you could put it into Lambda and you would have a tenth of the bill, but still maybe like $9,000 if it was all Lambda. Probably more in CloudWatch bills. Not super fun. But that same thing could probably be like $500 if it was running in EC2, and then it could be $100 on Hetzner, and it could be just electricity if you own the server. All of that is true. Like every point at that spectrum is true. I think that's why people argue about it so passionately, because they like, for them, they see it as a factual discussion and not a spectrum of features. And that's where I think the discourse is missing on the serverless versus self-hosted, is that there's like the spectrum of the time to market and the like what features you get out of your service. Like AWS is by far the easiest way to use a billion different services at once, for sure. And eventually, like, I use all of these every day, basically. That's a lot. Like if I want to use this everywhere, Hetzner's not giving me this. So yeah, like you make a choice. Where were we? Oh, we're compiling now. Cargo build. Sweet. Oh, 1 second. I have to go fuzzy to make sure I have these environment variables on. All right. 1 second. We're just going to export this. Oh, Duct Tape DevOps. Thanks for the follow. Great name. I don't know. Maybe you're a content creator and I haven't seen your stream before, but that's a great name. Oh yeah, hell yeah. Look at that. You get your own emotes too. Super cool. Marcos, so we are hacking on, I will unfuzzy my name, or my screen just a second. We're improving the cold start benchmarking setup. Frenzy in YouTube chat asked, can you add Alicia to the benchmarks? I don't know what Alicia is. I can look that up. What's that? Okay, almost done. 2 more. Sweet. Haven't been streaming as much lately, but was streaming SageMaker. Oh, cool. SageMaker is a surprise build generating system. That's what I've heard. I've only used it a little bit. Okay. All right. Oh, hell yeah, we panicked. Okay. Oh, we don't have, okay, that's perfect. That worked great. Okay, so I think this is one of the coolest experiences about Rust that I love, actually. Actually, chat. I fought my way through a bunch of code that I have written maybe once in my life before, join sets. I knew roughly I needed to do this. I had a couple of places where I had to, like, chat help me about the while let some result crap that I let Copilot suggest and shouldn't have, and that is what took the longest time. But I refactored this all, and it compiled and it worked the first time. And that is my biggest experience with Rust, is that I spend all of my time here in this editor getting the code to compile and, you know, adding the feature I need. But when it comes time to compile and run the software, it tends to be just like basically correct. And it's awesome. Like, that part I really love. My first 2 months were over 2K per month until I learned how to use it right. Tofu destroy. Yeah. Ooh, yikes. That will get you. What is, okay, Frenzy asked about Alicia. I don't know what that is. Alicia. Oh. Is it a language? AliciaGS.com. Frenzy, I don't know if this really matters to be benchmarked because it's probably going to be pretty close to just Lambda. An ergonomic framework for humans. It's a web framework. Okay. It'll probably be close to Hono. Official Tech Empower benchmark. My benchmarks are not official. It's interesting that it's faster than Jin, though. That is a little surprising. Yeah, we could maybe look at this. It's kind of neat. What? It did nothing. I don't think it did anything. Oh. Never mind. I take it back. Wait, no, it didn't do anything. What did I don't think there's anything different. What am I missing? Chat. Tell me what I'm missing. Pull up. That's right. That guy Dora. Why am I typing query string parameters into chat or into my URL bar from chat? We can check it out. That's pretty cool. Oh no. Am I being... Oh no, it's just nothing's happening. Okay, that's fine. Dark Lord willing. TweetDeck used to be good, and they kind of wrecked it. All right, this is sweet. So now, what do we got? So now we have a join set. Kind of neat. Do we want to do... Here's a real question. Do we want to do multiple points? Or do we just want to run the... I think maybe even running the request at the same time is probably good. Let's get this out. Okay, so let's Docker build. Docker build, and we'll push it. And let's get this running on the NAS, because I want to have them running in parallel first. Very cool. Bum, bum, bum. The shirt has such riz. Sally the Goose, welcome back. Thank you. Yeah, this is the shirt they gave us at reInvent for being AWS heroes. I gotta get a cord that doesn't sit in front of it. The shirt has riz. The man does not. How many points are you looking to get? George, that's a good question. I want to call it like probably a week. I like to look over the course of a week. Especially because like vercel and AWS are always working on stuff. So over the weekend, I would expect them not to deploy any like big changes over the weekend. So then I kind of want to see what it's like on the weekend and then what it's like during the week. A Bug Slayer shirt on Twitter? No, I haven't seen that. Send it to me. I'll take a look. AWS certified socks. Yeah, I've got some AWS socks as well. What was I gonna say? You get like a jacket if you complete all of the AWS. You get certified for all of the AWS certifications. I don't have any. I've never done an AWS certification at all. Hero, by the way, but no certs. So I don't have that, but I see a few people every year doing that. I think that's pretty cool. Still building. Cross compilation with QEMU and Docker buildx. So what do we want to do here? Do we want to run multiple requests? We could do that. Deductive DevOps, I don't actually know. They don't tell me. They just invited me. I got an email that said, would you be our hero? From the program organizers. And I know like roughly what I did. I gave a bunch of talks. I created a bunch of blog posts that became sort of canonical references for things in Lambda. Like if you search Lambda layers, you'll get my blog post. If you search like containers versus zip cold start or any of that stuff, you'll get my blog posts. I discovered, much to their chagrin, I discovered that they were warming up Lambda functions for users. So that was a big blog post as well. Yeah, so I think it's a lot of that. And then also at the same time, like my company's a partner with AWS, so we sit in on a lot of their briefings about, you know, what features they're working on, and we give them feedback on it and try and speak for what our customers would maybe like. Yeah, so I assume that's a lot of it. I think it's kind of all part of it, but they don't actually tell you. They don't tell me what it is. Nicky T. Okay, yeah, I follow Nick. Actually, he's got some cool content coming out too. I know this name. Bada-bada-bum. Yeah, we follow each other. Oh, that is sick. Yo. What? Sentry? What do I got to do? I have mutuals at Sentry. That is so cool. Yeah, that's sweet. Got to get one of those. Very cool. We're building. Yeah, so yesterday, I'm shocked. Okay, shout out to Synology again for sponsoring the stream. We got this whole thing set up. We took it out of the box on stream yesterday. Completely, you know, whatever. Pulled it out, set it all up, and had this entire benchmark running in Docker in like 2.5 hours. It was awesome. I remember being a meeting with the PMs for ECS and EKS over who had Docker exec. I don't know, like, I don't think it came from their, I don't think it came from their PMs necessarily. I think, I don't know if it's like its own organization. AWS Docker login. Oh no, how did I fix this yesterday? Oh no. Shit. Okay, first off, yeah, let's Yeah, this is a whole fight yesterday. Chad, do you remember this? Docker logout. Docker logout AWS. And then it's AWS Docker login. Yeah, did I do? No, but I couldn't have, come on. There's no way the last command is absolutely the right command. Like, we definitely did this right. No, I went up. I didn't. No, I didn't. Yeah, it's the same thing. What the hell? And this is the exact same command I have. I literally have this one. Okay, whatever. Okay, that worked. I don't know what it is, man. Maybe I gotta update my command. Maybe my command logs into a different AWS account. That's fine. Okay, so we pushed it. Oh no, I forgot this is running ZSH, or not ZSH, just SH. Okay, so we gotta pull the latest. Boom, boom. Oh no, I have to log into this one too. That should just work though, yeah? Hell yeah, okay. All right, we have the layers, we pulled the image. Okay, this is good. Now we have to docker ps, docker rm. What is this command? rm-fv? Yeah. Kill the container. 22 hours. 22 hours of data, not too bad. So we'll kill it. Docker history grep docker. What is the docker command? Docker run. Yeah, here we go. This one. Okay, so my env file is here, which is not smart. It's my home directory. Okay. Spawn this off. Docker ps. Yeah, you only need the first couple bytes. 2 bytes of the hash. Docker logs f. Wow. Okay, we got metrics. We got metrics, chat. So that's working. We didn't get a panic. So okay, we'll watch the logs. So this is again on the NAS. So this is on this machine. Whoop whoop. Virtual computer happening. Here. So let's go back to the Rust project. What do I want to do here? Do we want to? There's a bunch we could do. There's a lot we could do here, actually. I think what we want to do is run multiple requests. No, George, I have not set up S3 Glacier. That was something else we could talk about. So I moved a whole bunch of base jumping videos onto this. So now I've got like hella videos from here. Actually, we should look. Where's my... no, not here. Boom. Storage manager. Yeah, so we used a full terabyte now. I moved a terabyte onto this. So we could set up Glacier. That might be a cool thing to do. But I also kind of want to keep poking around. We're close on this thing. So we could do... What would be the architecture for this program? What would be the best way to make this program work? So we would want to... what I'm thinking is we want to make multiple requests to the same... like concurrently to the same function. And that will like guarantee we always get a cold start, I think. Because Vercel's doing this like paid plans have one warm, like everything gets one warm execution, which is kind of neat. But I wonder if we can, like, I think because I haven't redeployed anything, that hasn't applied to my functions, which is fine. But I wonder what like the scale out cold start difference would be, because that it could be something different in their invoke plane that may be more or less, speedy. Maybe we want to tweak that. Also, if you're writing Rust, don't do what I do. I have like 100 of these expecs all over the place. This is going to crash your function every time that runs, so you want to match and handle that error. Now that I'm reading my own code. Boom, 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 boom. So you could put a couple of results, and then we could loop through them. That'd be kind of neat too, because we could then like sort the results or throw them out, or we could make. There's a few ways we could do this. We could make the request and then see what the shortest one is and push that into the result. index by a function name. But then we'd have to pick the slowest one, and do we want to do that? Because here's the question, like we've got, okay, maybe it helps if we draw this out. All right, where were we? All right, so we have many of these functions running. This is now, I need the synology logo. Hell yeah. Logo. Oh, we could also forward logs. That'd be cool. Boom. Okay, so now we have the synology. Oopsies. Okay, so now this box is sitting under my desk, you know, and it's making these requests. But one thing we could do, one thing that Lambda does well, and that you know, vercel by virtue of using Lambda does, is it scales out really fast. So we can maybe make like a couple of concurrent requests here. But then now the question is, what points do I report? Do I report all of them? What's the metric datum request? Is that allowed? Okay. Values none, counts none. Oh. What data is this? Oh, so maybe we don't want to part this publish the statistics set. George, all the cold start ones should be valid points. Yeah, correct. They're all going to be valid points. So that should work. That's fine. I think what we want to do is just, maybe we'll just rip through and add a couple of, like, do this twice. None of this is right. Set.push. That's not right. Is this even right? Is this syntax even right? No. I've not written a for loop in Rust, I realize now, not with iterators, or not without an iterator. Rust for loop. Google, go. 5 loop expressions. Loop while. Oh, we can do loop while. Okay. I is less than 10. We can do that. Do we not do? Oh, it's for n in. Oh, we can spread. That's cool. Does it not do just a regular for loop? That's funny. Doesn't make a copy of the variable. That's true. What do we want to do, chat? I mean, the spread operator is fine. Oh, loop labels with lifetimes? That's probably the most complicated way. We'll do while, yeah. We'll just do a while loop. I know. Oh, we can just, it's fine. Ownership. Okay. 3 runs? 3 runs on good chat? 0.3. Yeah, 0.3 would do a copy. I'm actually not sure. I have to look. Nixia, hey, Mr. Krabby McCrabface, come on. I look great today. Okay. Chad, what do you think? Should we do 3 and see where we're at? Let's see what CloudWatch looks like now that we pushed a bunch of points. Give it a minute. Give it a minute to ingest this data. Oh, interesting. We just got a point where vercel beat Hono. Look at that. Because right now I'm just sending them all, and then we're letting you know, CloudWatch decide. We could pick, but I don't know. Like the question is, like, statistically, what's the best way to do this? And I think the answer is, like, get all of the points into CloudWatch and then decide with, like, a trimmed mean, and not necessarily, like, throw one out, because we're not going to collect the point if it's not a cold start anyway. So I think just getting 3 runs is probably safe. Or do we want to vary the number? Is that the question? You know, because like I said, proactive initialization is a thing. And at some point, whatever model, system, whatever they're doing, you're going to have more warm sandboxes, because it knows that I'm suddenly making 3 requests. It's an interesting question. This is going to wait 15 more minutes, but what do we all send? Yeah, I think let's build this. I think let's ship this. Not parallel. Thanks for the code review, chat. What else is going on the internet while this builds? Reference to your Rust, not your face, by the way. Fair enough. Have you seen the new warm-up function behavior? I have not personally seen it. I haven't looked for it. We could deploy one and check it. They already do warm-up functions for you right after you deploy, which is kind of neat. You can see that pretty easily when you deploy in vercel. I think that's a great feature. I think AWS should do that for sure. But I've not seen their, you always get a warm, yeah, where is it? Where's their company news? Where is it? They announced it. Oh, here we go. Where is it? Vercel cold start. If I don't rank on this keyword, I'm kidding. Oh, yikes. It's a year ago. Here we go. 4 days ago. That's it. Joe and Gal. Vercel's infrastructure now keeps a minimum of 1 function instance warm for production environments on paid plans. Oh, we could set it to prod. Improve startup times for low. Yeah. Did I not do that? Is that why I haven't seen it? Marcos, yeah, I think we did. Mount type cache, target user local cargo registry. Did I do that wrong? Also, welcome back everyone who's been hanging out with me this weekend. Thanks for hanging out. Mount type cache, target user local cargo registry, cargo build dash released. What did I goof that? I can look. Not feeling good about serverless corp stuff. I used to work there. I worked there for a long time. Yeah, Marcos, we can take a look. But let me share thoughts on serverless. So serverless framework, I worked there since V1. Was there for 3 years. It's still a very popular project, very popular framework. They're moving to a V4 model, which is like they've done a bunch of different things, but they're moving to this V4 model, which is specifically licensed differently, and anything above $2 million, any company above $2 million in annual revenue has to pay like a per headcount fee. So I think a lot of people are sticking on V3. I haven't seen anything in V4 that makes me want to do, makes me want to upgrade. So this is frustrating. This is extremely frustrating. I think this is the part that really soured me on it. They're locking new runtime support in the framework behind an upgrade to this, but it's a one-line change, and the open source community already opened a PR. Kochi, hey, welcome back. So, this has been open for like well over a year, and it's literally a +2 -1. It's a two-line change to support this, and they're saying no, you have to upgrade to V4 for this, and I think that's pretty shitty. So I mean I commented on this, like this, I think someone should fork serverless framework at V3, because everything else, build a feature, sell it, you know, make something good that people want to pay for. This is not it. Like this is not it. This ain't it. So SSO classic upgrade. You know, like use SSO. Okay. So yeah, that's kind of my take. I think someone should fork it. Sorry. Like I was there for a long time, worked really hard on it, have a number of friends that I met through there, including like another AWS hero, Alex Debris, like the legendary DynamoDB guide author. Lots of great people worked through this, came up through this, but like, I don't know. This is not it. They're not doing the right thing. Okay. What did Marco say? Okay. Docker run -v pwd :source. Oh, that is just executing it though. Why is it now running bash? Oh, because I set entry point. Oh no, we did it again. Oh, the raw rust image. Docker kill. What is it? Docker rm. There we go. Okay, kill this. How do I force stop it? Is it -fe? Yeah, force. Okay. Oh, not curler counter. You meant. Oh, the actual rust image. Okay. Which is what? Rust Buster. Where did my... It should go into /source, right? Oh, yeah. Okay. Teach me all these sweet Docker things. Marcos, appreciate it. Stuff that I should know or probably learned at one point and just forgot. You worked at Docker in 2014. Nice. Good year to work at Docker. All right. Well, this compiles. I'm going to go pee. Be right back. 1 second here. What do we got? Okay, so now we want to close out of this container, right? And then run docker diff. And then it's the container ID. Oh, we need a separate one too. Oops. User local cargo. That's what I did wrong. Oh, no, that's right. User local cargo registry. Is it maybe the... Marcos, how do I pass it the second container to diff? Or does it just know because I'm in the current working directory? Yeah, it just knows it's diffing against my other container, right? Yeah, I wonder why it's not caching. Yeah, nifty. I was just talking to my wife about it. It's going to 5. Does it work without the platform tag? Oh. It probably is the platform tag. What would I have to do for that? Just do like a Docker build and then remove the tag. Remove platform. Yeah. And then we should be able to do Docker diff. All right, we'll try that. And we can just see how much faster. Oh, glibc is now being now complaining. 229 not found. 234, 233. What the hell? It's like the base image no longer is linking against an older version of glibc. Yeah, because I'm using 178 Buster. It's got to be a new enough version. I don't know why. That's a weird error. That doesn't make sense to me. Why would that work with the platform flag then? Weird. Yeah. That's so strange. Why would that have a different version of glibc in the x86 versus the AR64 version? That's wild. That doesn't make any sense. That makes no sense. That's okay, though. I guess we'll just let it build. I don't know why that's not working. Oh yeah, we don't have any cold start. Okay, well let's get this built. We'll push it up. We'll get it running. We'll run the multiple, and we'll get that data in there because we pushed it all from my laptop. Boom, boom, and we'll see. It should be all here, right? ACW growth. Yeah, okay, we got that. Good, we pushed that. Oh no, the Docker file is starting to grow. In my this was a pure Rust project when we started this weekend. Yeah, that's so strange. I wonder why the version of glibc would be either different or missing or what. Oh, I'm not using... No, I mean, it's the same. It's Rust 178 Buster. Right? Yeah, 178 Buster. And then Bullseye Slim is just our runner. I don't know. Is it an older version? That doesn't make sense. What's the current glibc 2.34 was it complaining about? That's 2021. That's not that bad. The C library. The C library. Oh well. Who's hit me up on X? What's happening on this website? Could you do Cloudflare worker for comparison? That's a good question. We can. They're just so different, right? Well, no, Marcos, they're all working fine. That's what's so wild. It's working fine on AR64. Why would it not work on x86? Oh, sorry, you're right. But it's working fine on M1. Yeah, I'm building it locally on Darwin. I'm not hard coding x86 either, and it's not like there's an, because you can put the plugin, you can put the buildx plugin artifact there. We should fix I just realized the text is probably a little goofy. We fixed stream parrot yesterday. Let's fix this quick for the names. I think the names are still kind of goofy. They're all hard to see. Overlay. Colors. Default username. Do you want to do like a orange? Oh wow, we're all over the place now. Let's try that. Boom, boom, boom. All right, this will take, that is not the color. This will take a minute. 30 seconds. Yeah, I have no idea why Docker is fighting me here. That doesn't make any sense to me. glibc not found. Marcos, yeah, send me some docs on that. Best solution would be to create a Docker context that talks to the Docker daemon in your NAS so I could compile on my NAS. Is that what you're saying? Like I could compile on the box? There, that looks good. Okay. It still looks very dark on screen. It looks fine here, but it looks dark on screen. Whatever. Yeah, we can do that. Send me the docs. Okay, this is cool. Docker tag. Docker push. Boom. All right, where are we here? Docker pull. Zoop. Hell yeah. Sweet. Okay, we pulled the image. Now we need to remove. Okay, hell yeah. Send me this. What do we got? Oh, cool. Okay, so I can just SSH as myself and switch content. That's sweet. Okay, that makes sense. I have not had to do this before. Very cool. All right, I'm going to go ahead and give that a bookmark. Thanks, Marcos. We can probably do that next stream. That's pretty sweet. I'm sure the fine folks at Synology would be interested in that too. Although I think they got to be pretty pleased with where we're at so far because this all worked in a day. That's just so impressive to me that this all just worked in a day. That's so cool. Okay, Docker. What do we do? Docker PS. Okay, let's stop this. My fingers just typed -rf. That's so funny. Run new curler counter latest. That sounds good. Cool. We can try Bookworm. Let's try Bookworm. What is it? Docker logs -f, right. Okay, there we go. So we got some points, but not all of them. Sweet. Look at all these points, chat. We are sending some data points. Uh-oh, Marcus Marcos, you sent me ... points. Yes, data points. Metric points. Metric datum, which somehow is hilariously least descriptive than just points. But yes, these are points. Let's try bookworm. There, that's working. Yeah, you're totally right. It's just an older version. Buster must be an older version of the kernel, and it's got to be on like 2.29 or something old. Joich, you're the first person that I noticed also using datum. Why? Who else would? Oh, you'd use it if you send your own metrics to CloudWatch. Let's go. Oh, we haven't replied to Twitter. Okay, so while this builds, Buster's Debian. Oh, OS libs. My bad. That explains it. This person sent me a note. Okay, could I do Cloudflare workers? So maybe. I don't know. Maybe that is something interesting to compare, though, because like the hard question is going to be like, can we build a small app that works the same everywhere? Yeah, it's not apples to apples at all. And like, it's also, you've got durable, what do they call them? Durable functions or whatever, just like microservers. Now change something in your app and rebuild again, see if caching works. Yeah. Boom, boom, boom. It is still compiling everything. Didn't even notice. Welcome to chat. Thanks for saying hi, dropping in. Appreciate that. Vercel edge functions and Cloudflare workers for more apples to apples. Yeah, we totally could. No, George, I don't think that worked. It's still compiling. It shouldn't have to recompile hyper because it should cache the dependencies. That's what Marcus has been helping me with. Didn't even notice. Thanks for the follow, man. Much appreciated. I wonder why that didn't work. I wonder why Docker didn't cache that. Yeah, we're trying to exactly all of the. So if you haven't looked at user local cargo registry, we can, right? Like, oh, it won't be here. Never mind. It would be in the container. I'm an idiot. But in the container, we like when you download a bunch of Rust dependencies, they get cached into a directory. The layers are Docker layers are defined by the commands though. So this one build command like downloads everything and compiles them at once. We could split that to like cargo add which would just be weird. If I'm honest, though, chat, I'm a little less interested in the edge. Cargo chef. Welcome to chat. Future highway. Cargo chef for this? What? What are you educating me on? Oh. Yeah, it's all good, Marcos. What if we read the code for this? Is this recipe? Oh. In Alpine, does anyone read this and say Alpine? Do we have any F1 fans in chat? Let him cook. Thanks, that guy. Let him equal cook. There we go. There we go. You need a semicolon there as a statement. This is cool. Automatically pick up all crates in a workspace. That's neat. Yeah, definitely didn't work though. But not bad. I mean, we can keep using that version. And thanks again for the follow. Didn't even notice. I really appreciate it. If you're new here, if you're just dropping by, if I popped up on your Twitch or on Twitter, please feel free to say hello. I'm AJ Steivenberg. I'm a staff engineer at Datadog. I work on serverless observability for Datadog. And then in my spare time, I write little Rust projects like this, or just any project, and benchmark and test serverless platforms. So this week has been a really cool week because my friends at Synology hooked me up with a brand new 4-bay network attached storage device, which is under my desk now. We set that up yesterday. So that is running. We are over here, and you can go and look, and we've got our containers. So we're running our project right now, and it is benchmarking vercel and a few other things. So we can look. Do you have any more logs? No more logs yet. Anyway, thanks again. Hit that follow button if you're new. Much appreciated. AJ, could you try adding the target folder of the curler counter to the run cache as well? Basically, add another mount flag. Sure, let's try that. Another mount flag to run here. Equal type, equal cache, target, equal, do I need the whole directory, or can I just do / curler counter like this? Do I need like a fully qualified, or can it does it know /? Should be okay. All right, we can test this. Also, and huge thank you to the Primogen, who did a whole video talking with Dax about my work. That was pretty cool. Didn't expect that. That was really, really neat. All right, so we're gonna compile it once, then we'll tweak something, and we'll compile it again, and we'll see if the cache works. Oh, /count. Okay, we can. Yeah, 1 second. Yep, you're right. Because this is on the destination machine, right? Yeah. You think that's it? Okay. Why does it need 2 flags? That's interesting to me. All right, we'll let this compile. We got some more points. Oh, very exciting. That's just the syntax. Okay. There we go. Okay, so we got, look at this. So AWS has been on the floor. But we had a little bit of an uptick, and I wonder if that's because we had a couple more, the proactive inits now became actual cold starts. Well, no, we would have counted the proactive inits. That's fair. Hono is back to being in second place, and weirdly enough, serverless HTTP took longer than LWA. That's cool. Very cool. And I think we can see the raw points if we go here, go to data table. Look at that. Very cool. Sweet. Okay, we're still compiling here. That's fine. Yeah, I do think, I think we should do some edge stuff. The question is also, do we want to do edge stuff, or do we want to do response streaming? Because that's another thing that I wanted to look at. Vercel has implemented the response streaming themselves in their K8s layer, and I want to see how much faster or slower that would be than AWS Lambda's response streaming. And maybe that would be cool, because I don't know. I really have no idea which way that one will go. I have no inclination. And how will we test that? I think we'd have to test that in terms of stream a kilobyte or stream a megabyte from the function of either random data or just JSON. So I'd put some lorem ipsum text into the payload, stream it back line by line, and see how long it takes. That might be okay. That would be cool, but it also might be less important, because I think half of the whole response streaming thing, half the latency there is going to be CPU to actually compute the change you need to make. you know, like whatever data you are streaming, or like, you know, latency to your database or something. And that's like a little trickier to do in a benchmark. A little trickier. Not impossible. This is sweet though. Thanks, Marcos. Okay. Oh, here we go. nvim src main. Let's just remove the log. Oh, hell yeah. That's way faster. Yep, that worked. That was it. You're right, Marcos. Oh, amazing. Thank you. Build cache is working. Sweet. Okay. What do we do? Okay, so we had to switch to Bookworm because we needed a different set of depths for some reason, which is weird. Oh, we should try the Docker build with the platform. Make sure this still works. Awesome. Thank you. Thank you. That's super helpful. This will speed this up dramatically. Super exciting. Okay, this is great. This is going to go faster now, and we're testing with more requests, so we'll get more data. And then, yeah, we should test response streaming. I think that'd be cool. But I also really want to do Docker contexts, like Marcos was telling me, because being able to build on the box would be neat. It'd be faster than QEMU. QEMU. Justice, hello, welcome back. Thanks for saying hello. Thanks for dropping by. Good to see you again. Happy Sunday. QEMU. QEMU. Kimu. Is that what you say? Fair enough. Fair enough. Quimu. QUE. Someone's gonna drop into this channel and be like, what am I watching? QEMU. All right, one more painful build and then it'll be cached. What am I watching? Kochi, good to see you. Marcos was helping with the build cache for Docker, so he didn't recompile our dependencies every time. We're just making heat. One of the systems programmers I work with was helping me learn Rust. We needed it for Lambda because it creates really small, very fast binaries. But mostly, you know, we use it for these large applications, these large stateful applications of Datadog. And he was leaving a code review on one of my PRs, and he saw a place where I had like a loop inside of we were moving from system threads to Tokyo tasks, and I left a loop in there, and he said this loop is just waste heat, and that's what he started referring to every inefficient bit of code as waste heat. He's like, you're just creating heat here. Small binaries, isn't hello world several megabytes? No. So hello world is like under one, couple 100 kilobytes depending on what you ship. It's quite small. If you remove the panic handlers, so we strip that out, it's really quite small. I think our current build is like 2 megabytes with a ton of data, like a ton of libraries and stuff in it. Electron, hello world. Electron. You know, Slack is good. Like I don't mind it so much. It's, you know, beefy. It requires a ton of CPU, but it works. Tori is goated. Thanks, Justice. Kojak, welcome back. Good to see you again, man. Increased entropy. The heat death of the universe will come for my compiled binaries. This is sweet. This has been a super fun weekend. I'm really stoked to get more data over the week. I'll tweet it out when we get more data. I think we're good at 3. We could do more. I mean, so what we're doing right now, if you're just joining, we'd modified this Rust project to make more concurrent requests, and we did them concurrently as well. And I think the concurrency is an important part. We should look at the number of threads Tokyo main this macro gives us by default, but I think it's 1 per core, maybe more. But the whole goal is to make these requests as synchronously as possible. Did you get a reply from vercel about past week's datums? No, I've not heard from vercel in a minute. They've been super cool every time I talk with them, though. I do want to. They asked me to test out their their bytecode caching, which I kind of want to do, but I don't really have a comparison point. And also, I don't have a big Next.js app. So I don't really, you know, they're like, well, it works best when you have like a larger application. Justice, what was the advantage of join set over futures unordered? I don't even know. Join set versus futures unordered. I just had used join set in the past. Oh, okay. I think that's literally it. It's just like join sets specialized for Tokyo. Maybe it just makes the types easier. When I'm like pretty firmly in the Tokyo camp now. I was able to drop it into a project that was using system threads, and for me, it improved performance across every dimension, including cold start performance, which is pretty neat. So I'm pretty happy with it, and I'm kind of just going to sit with it. But I believe it's faster. I find Rust in general is already pretty good with asynchronous programming. However, one thing that I think Tokyo does better than Rust built-in threading is that in the case where I have a Lambda function with like 128 megabytes of RAM, multiple threads is just extra context switching, and that just hurts me. So then having user space threading is actually like a little bit of a performance advantage there, in my experience, from what I can tell. It could also be that my Rust code was like super bad, and then Tokyo just helped clean it up. But yeah, I got a little bit more performance out of this doing this. Sweet. Okay, so let's make sure this works. So now we're cross compiling. Let's make a change. This should just fly. Boom. That's perfect. Marcos, thank you. Thanks everyone for helping me on this beautiful journey. That's so sick. Okay, that works great. The Docker file you sent me also, yeah, I read that the other day, Justice, but I didn't look at the caching. I was looking at the, was it removing the panic handler and something else? Yeah, we rolled that into our project too when we added Tokyo. I could test that though. Very cool. This is sweet. Okay. Oh, hell yeah, we just got more points. Okay, which means we can pull this down. Okay. Well, we didn't really change anything functionally, though. We did change the OS of the builder, so that doesn't really matter. Do we really have to redeploy this app, chat? I don't think so. Look at these numbers. This is just lovely. More data, more points. Let's go. Ooh, trending down. Is this Docker from scratch? No, I use like a Slim Debian to run. And then I just use, we're not using like an Ubuntu image to build. ChatGPT generated yesterday and we just went with it. Or Copilot did. It worked fine. Yo, thanks for the follow. Mizut. Welcome. Thanks for hanging out. This is sick. No, they haven't responded. I don't expect them to respond. I don't even know like what they would say. I know there was some consternation about, you know, as fast or faster than classic Lambda. That was the thing that blew up in Prime's video. Did everyone watch this? God damn it. The big problem with benchmarking serverless is that ping doesn't work on serverless because there's nothing to ping. Hey, thanks, Mizut. Hope you like it. Yeah, I do work at Datadog. Been there for 3 years now. Glad you use it. If you haven't seen the video, I don't think... Wow, dude, these videos go crazy. I can't believe how many... Yeah, observability is absolutely key. Why do they do this every time?
All right, so over the weekend, I don't know how many people saw, but there was a bunch of tweets going back and forth between pretty much Dax versus vercel is what it looked like, whereas AJ from Datadog was just providing numbers, and everybody else was providing an insightful amount of misinformation.
I didn't know he did this until someone sent me that clip. I was dying when I heard that intro. This could be. We don't. It's a long video. We don't have to watch it on stream. I'll plug it into the chat. In my simple project, I had a from scratch over Alpine plus the other ops I had in there to reduce the image size by 85%. That's sweet. We're not shipping a image. We're copying the binary out, so that part doesn't necessarily matter to me. But it does make it easier to move stuff around. God, this video is so funny. He was super nice to me. Where's the...
So this was then kind of where it shifted a little bit. Theo says, vercel continues to request to fix Lambda. Ryan asks to clarify, isn't this just speeding around build stuff?
Cold start that happens to be slower.
Okay, yeah, so we're talking about cold starts. I responded here. This is fine. Like, again, I think the response I got from vercel there was fine. Where is the...
Yes, we'll get this fixed. Okay, good.
Oh,
so
yeah.
My actual perception of this was benchmarking, and because AJ is so freaking thorough, he did something that nobody ever does, which is he went and read the terms of service of vercel.
That would be most certainly.
Which reminds me, actually, so that was hilarious. It did something that nobody ever does, read the terms of service. They said they were going to change this. Still hasn't been updated May 1st. Okay, so they haven't changed it yet. But I think they're still working on it. He said, Guillermo sent me a DM and said they were going to change this. They were going to, he didn't explicitly say they would remove this, but they were going to alter this clause. So I have permission for this, but yeah, they did say they were going to change it. Legal stuff is always slow. Yeah, George, it is always slow. And that doesn't, like, to be totally clear, that tweet did kind of go a little viral, or at least viral for me, right? Had like a few hundred likes on it and, a few thousand views. But they were right away reached out. The new TOS says, hey, you can't read the TOS. No, it's not what it is. The new agreement that we've all made is here, my license file right here. This is the key MIT license, but by reading this, you have to follow me on Twitter, subscribe and like on YouTube, and follow me on Twitch. Those are the rules. I didn't make them. I just created them. MIT V2. Yeah, I live right over here by MIT, so I'll just go over there and talk to them. Checkmate. We got him. Chat. We got him. Right here. Sweet. Okay, so we pushed this work. That's good. We're running. We got more points, more data. That's lovely. This is sick. I think we'll probably have to call it here for me. This is probably going to be it today. We got to figure out something to raid. This has been super fun. We're going to go probably raid LL Cool Chris. And then thanks for hanging out, and thanks for all the help with the Docker build stuff. That was super great. I will keep everyone posted as to the results of this benchmark. And you guys soon at the end. Yeah, sorry, Justice. I start streaming at 11 a.m. On Saturday, Sunday. So yeah. But thanks again for everybody, and take care. Have a good rest of your week, and see you online.
Même pas un peu. HTTP client, donc est-ce qu'on ferait pas une structure pour ça là? HTTP client, def module, tac. Hey, how are you doing? Welcome. All
right, for real, gotta leave.